Hi class, welcome to Art Principles. Class 6 or 7? What did we do last time? You remember? Okay, I'll remind you. We looked at three-point perspective and we talked about orthographic projections. Orthographic projections. And what we're going to do is work through an orthographic projection problem and then talk about some of the stuff we've already talked about. Now, if you look at this object, remember, this is the top view. This is what it would look like if you were looking straight down on it. You couldn't see the sides or the front of it. This is the front view. You can't see the top. You can't see the sides. You can just see the front. Also can't see the back or the bottom. This is the side view. You can see the sides, but you can't see the front or the back or the top or the bottom. And when you put all these together, what does it look like? Well, I didn't talk about the dotted line here. A dotted line in an orthographic projection is a hidden line. And that means that this is probably a cylinder or a hole drilled through the center of this block. And from this view, you can tell that from this view and this view, this is a cylinder running through the block. And you can tell it's a block because there's a square here, a square here, and a square here. Okay, let's draw this. Let's draw this. Now we're going to be drawing it in two-point perspective because this is the line of sight right here. We're looking into this corner at 45 degrees. 45 degrees. In other words, this angle right here is 45 and this one over here is 45. So we'll use the normal two-point perspective relationship with a vanishing point left, a vanishing point right, line of sight vanishing point, and two construction vanishing points, and the station point at the bottom. Now remember, normally the station point is located the width of this picture plane out here. But what we did was to move the station point from here to here. In other words, the station point is directly under the picture plane. So this is the station point right here. We're standing with the picture plane running right through our eyeball. And our line of sight is running right through the horizon line. I'm looking at there. That looks about right for the horizon line. So what we're going to do is draw a perfect cube. Start out by drawing a perfect cube. And we'll arbitrarily put the height of the cube right in the center. And this is going to be two-point perspective. We're only going to use two vanishing points. I'll use the vanishing point on the left over here and draw the tracer lines out. And I'm having trouble getting started here. Construction lines, remember, what's the difference between a construction line and an emphasis line? The construction line is really, really light. In other words, you're trying to figure stuff out with a construction line. And the emphasis line is after you figure it out, you then darken the line up. Now, this is going to be a perfect cube, so we have to use the construction vanishing point right and construction vanishing point left. So what we're going to do is measure this and do a construction line along the bottom that length. That length. Then we're going to use the end of this and that construction vanishing point over there, construction vanishing point right, and draw a construction line over. And where that construction line intersects this emphasis line here, not emphasis line, construction line here, where it crosses, this distance here is equal to this distance here in perspective. Now I can go ahead and finish the rest of this because I've got the top of it. All I've got to do is go straight up from this intersection right here, and I've drawn this side right here. Now I'm going to draw the other side, and I'll do that by measuring out here, the height of this, go back to the construction vanishing point left, since it's to the left of the line of sight vanishing point, and I get that intersection, and I draw the vertical there. Now remember, this is two-point perspective, and the 2 points we're using are this one and this one. We're not using the line of sight vanishing point. We are using the construction line vanishing points, but that has nothing to do with the look of the object. Now, after I get that intersection of the top, I can draw the left side of this block in. Now all I have to do is draw the top, and that's fairly easy to do because that far side is parallel. The far side line is parallel to this line, which is parallel to this line, and all parallel lines converge to a vanishing point on the horizon line if they're parallel to the ground plane. So I draw a construction line back here, and a construction line back over there, and I've drawn the block. I've drawn the block. Now, this is the major part of this. You always determine what you're drawing by looking at the major form. For instance, if you're drawing a figure, the torso is the major part. So you learn to draw the torso first, and then you add the arms and the hands and the heads and the feet later. This is the major form here. So looking at the top view, it's just a circle in perspective. And since this block is sitting on the ground plane, this circle is going to be parallel to the ground plane, so the major axis of the ellipse is parallel to the bottom of the picture plane. So I'll draw a little construction line in here that's parallel to the bottom of the picture plane and draw an ellipse out of that. Now, here's a mistake that a lot of students make when they have something that looks like this. They try to put the circle in the side here like this. Well, what's wrong with that is that the major axis of the ellipse is actually going back to this vanishing point, and you don't use this vanishing point over here unless you're drawing the cylinder on its side. So what I have to do is straighten this up. So I'm going to now the major axis of the ellipse is parallel to the bottom of the picture plane. So I've drawn the top of this now. So I can mark that off. Now I'm going to draw the cylinder running through it. That's going to be fairly easy to do because it's running. If I'm standing at the front, that means this is the front over here. This is the front over here. Or it could be over here, but I've decided it's going to be over here. So what I'm going to do is just like I drew a line on the top of this box. In other words, if I put a cylinder on the side of the box and drew a line around it, it would be a shape just like that one right there. So I will draw an ellipse whose minor axis is pointing to the sides of the block. Here and here, goes over here. So that would really be a projection of this block, or a projection of this cylinder on the side of the block. In other words, if I put the cylinder on the block and drew a line around it and took the cylinder away, There'd be a hole in there, just like along the top. The difference between the ellipse on the top and the ellipse on the side is the ellipse on the side, the major axis determines its orientation. The ellipse on the side, the minor axis determines its orientation. Remember, the minor axis always points to the vanishing points at the sides of the cylinder. And if the cylinder's sides are parallel to the front and back of this thing, this is the vanishing point I would use. So the minor axis of this ellipse is pointing over here. And I draw out from there. I draw out here. Now it doesn't come out very far, so I'll stop it real quick and finish it off. And I may see a little bit of it back here, but probably not much of it. And this line will go back over there. You know, I'm going to go ahead and make this a little bit longer than it probably really should be. Just because it looks better. And there we have it. Orthographic projection using vanishing point left, vanishing point right, construction vanishing point right, construction vanishing point left. That allowed me to draw the rest of the objects related to the block as determined by the orthographic projection. Now I'm going to talk about, I'm just going to review the three-point perspective information I gave you last time. I'm going to start out with just the normal and in this case I'm going to be looking down. When I'm looking down, I change my picture plane to this orientation, to this orientation. So if I have any verticals here, they're moving away from my picture plane. So if they're moving away from the picture plane, the vanishing point is going to be below the horizon line. And all the verticals, instead of being parallel, are going to do this. If I was to look up, they would reverse out. They would do this. So, now, in three-point perspective, the line of sight vanishing point is where the third vanishing point is located. So this is the line of sight vanishing point. I think I'll make it a little bit bigger than this. Normally, you'll be using this if you're drawing buildings. Like this would be drawing a building on top of another building. Okay. Now, this one is directly in front of you, and you really can't tell whether it's leaning towards you or leaning away from you. But I know if I extend this line on down, it will be where that vanishing point is. So depending on how far I rotate my picture plane or how steep this angle is, this vanishing point can be anywhere along here. I want to make it right here. just arbitrary. Then I'm going to make an arbitrary length. So all the verticals are going to be going to that point. And all the verticals over here is going to be going to that point. So this is, now this goes over there. This goes over there. This is what would happen if I had a block on the table it would look like this. If I look down, it would look like this. Look like this. Now, up until this point, we've been talking about planes that are parallel to the ground plane, perpendicular to the ground plane, are moving away from the picture plane. What we're going to do now is talk about an inclined plane. First thing I'm going to do is draw just a plane lying on the ground plane. Using vanishing point right and vanishing point left. Now, if I was to take this corner here and rotate it around this back corner, I would have what's called an inclined plane towards me. An inclined plane towards me. In other words, if I lifted this front corner up to here, what would happen? Well, what would happen is I would move, this vanishing point right now is going back to this vanishing point. If I lifted this up or rotated around this back corner, if I draw a line through that back corner and extend it out to a construction line running through that vanishing point, I will create a construction vanishing point over here. And what that means is that I go from here to here, and if I rotate this one up, this is an inclined plane toward me. Now, if I keep lifting this up, in other words, if I go up to here, this, by the way, would make a huge ellipse here. Well, it probably wouldn't be quite that, probably more like that. So I would go there, go over here, go there, go back down there, wouldn't see that. I kept lifting it up. Now if I keep lifting it up, it's going to finally get vertical again. In other words, it'll be parallel to the sides of the picture plane. At that point, it'll look something like that. Now that's an inclined plane towards you. Inclined plane towards you. Now we're going to do an inclined plane away from you. Then I want to pick up this back edge and rotate it around this front edge. In other words, just rotate it around that edge there. So if I pick it up, it will go somewhere like that. This one is going to go over here. Now, what happens here is, what I'm going to do is I'll change that vanishing point from there up to here, and I'll find out where that point is by extending this line out and get a construction vanishing point right there. And the line on this side over here is going to go up to that construction vanishing point. If I raise it a little bit higher, it'll go from there to there to there. And eventually, if I raise it all the way up, the sides will be that's an inclined plane away from you. An inclined plane away from you. So planes don't always have to be parallel to the ground plane. They can be in all kinds of different ways. What you don't want to do is get it standing on the corner. You can figure it out, but it takes you a long time to figure it out. Just remember, whenever parallel lines move away from the picture plane, they're going to converge. It's going to converge. Now, I don't know if I've talked about this or not. Have I talked about the horizon line? The horizon line is an imaginary plane that runs through your eyes, wherever your eyes are. And it goes on all the way around you. And it goes infinitely in all directions. That's why the horizon line doesn't end at the end of the picture plane. It continues out that way to infinity and out this way to infinity. Now we're going to talk about scale, drawing to scale. Don't want to do it that way. Ground plane, okay, this is level by definition. A line of sight is parallel to it. Remember, the line of sight is always parallel to, I'm going to have to, this is just too bad right there. Ground plane. Picture plane. Eye level, line of sight, ground plane. If I lay a ruler on the picture plane and measure up 6 inches here and measure down 6 inches, that will be 1 foot. And at that point, at that distance, in other words, the aesthetic distance or the viewing distance is twice the picture plane. At that distance, 1 inch, or 12 inches, I'm sorry, 12 inches equals 1 foot. Now, if I take that distance and move it out here to here, in other words, I move the ruler parallel to the ground plane out here. And I draw lines from the end of that ruler to there. What happens is, whenever you double the distance away from you, you halve the length. So at that distance, this would be 6 inches. At that distance, that ruler would look like it's 6 inches. If I now double this distance to here, and move that ruler out here, and I draw lines from the top and the bottom, this will be 3 inches. Where it intersects, where the top, it'll look like it's 3 inches at that distance. So if I keep, 3 inches is going to look like it equals a foot. If I keep doubling those distances, if I do it again to here, move the ruler out, it'll half the distance. So 1.5 inches equals 1 foot. And I can keep moving that picture plane on out, and until that ruler looks like it's a 1/2 inch. So a 1/2 inch, 0.5 inches equals 1 foot. Now I'm going to play with this scale. I'm going to play with this scale. 1/2 inch equals 1 foot. Okay, I'm standing in a room. I'm standing in a room. And that's what I am. I'm standing in a room. And I'm actually looking right now to the back wall of Pinnacle Graphic Studios. I'm probably not at 1/2 inch equals a foot distance, but I'm going to show you how that works. Now, if this, let's say, well, these are 10-foot walls. I'm going to work with an 8-foot wall. This is an 8-foot wall, 8 feet. How many inches to scale would that be? Well, it would be 4 inches. So 8 feet equals 4 inches. The reason you use a 1/2 inch because it's easy to divide by 2. You just cut it in half and just add inches. So this is an 8-foot wall. I am away from that wall where the skate, where a 12-inch ruler would look like it's only a 1/2 inch. And I draw a line from my eye to the bottom of the wall. and a line from the top of the wall. Now I'm about 6'4". About 6'4". My eye level is about 6 feet. So I am 6 feet off the ground. So if I'm 6 feet off the ground, and if my line of sight is parallel to the ground plane, this is going to be 6 foot right here. It's going to be 6 foot right here. Then what's this going to be to scale? 3 inches. What's this going to be? Or 2 feet, right? 6 feet, 2 feet. So what's 2? So this is 1 inch. So this whole thing is going to be 4 inches. How do I know it's going to be 4 inches? Well, my line of sight is parallel to the ground plane. This intersects at the bottom. This will be 3 inches here. This will be 1 inch here. Now, how do I change that into a drawing? Set up a normal picture plane. This is 12 inches. This is 6 inches. This is 24 inches. With the drawing pad I had you buy, it would be this one right here. It would be this one right here. I would have a vanishing point over here, and a vanishing point over here, and a vanishing point right in the center. Well, we're not going to be drawing anything to scale. We're going to be drawing a wall that is 8 feet tall, and I am 6'4", or you are 6'4". So what I do is I measure down 3 inches. That would be 6 foot. I would measure up 1 inch. And I would draw a horizontal line. There, and a horizontal line here. Horizontal line here. And that's what that wall would look like. If it went on, if it was the Great Wall of Columbia, this would go on forever that way, and this would go on forever that way. But what we're going to do, we're going to make this into a room. We're going to be drawing this room to scale in 1 point perspective. Let me set up the interior of this. It would probably be easier over here. Let's say I'm standing 4 feet from the left wall over here. Anything to the left of the centerline vanishing point is to my left. So I'm 4 feet over here, and I'm 10 feet from the other wall over here. The line of sight vanishing point is going to be like this. This is my picture plane. I go from here to this corner over here, and over here, the corner over here. This is 4 feet. This is 10 feet. So if I measure to my left to scale, I can find the bottom corner of this wall. So I would measure over here, how far? 2 inches. Draw that wall. Then I would measure over here. How far? Well, it's 10 feet. What's half of 10? 5. So I measure over here 5 inches. So what's the size of this wall? 14 feet. So this wall is, to scale, 1/2 inch equals 1 foot. Eye level, 6 feet. The wall is 8 feet by 14 feet. We're going to draw that wall. So I measure over here 5 inches. This is 7 inches by 4 inches. That's a wall. I'm standing in a room that is 8 feet wide and 14 feet. It's 14 feet wide. Looking at a wall that's 8 feet tall. And my line of sight is 6 foot from here. In other words, you may notice that this line of sight is right along my eye level. Right along my eye level. Now, I'm looking into this wall, or this wall is parallel to my picture plane, so it's in 1-point perspective. So if I draw a line from here to the corner here, and a line from the bottom corner here, I will have drawn the left wall in here. If I do the same thing to the other side, I have now drawn a room interior where I am standing 4 feet from the left wall, 7 feet from the right wall, 10 feet from the right wall. I don't think I put that over there. Right wall. Now what we're going to do is we're going to take out our ruler, and every 1/2 inch we're going to mark off along the baseline, because every 1/2 inch is equal to a foot. So how many marks are going to be there? I wish we had some interaction here. You're going to have 14 marks on there. Now, every 1/2 inch, if I go back to this vanishing point here, Of course, mine's not to scale. If I had my ruler, I could do it very easily. Remember, everywhere there's a mark there, you put one end of your ruler on that mark. And you go back to that line of sight vanishing point, and you draw a line. And you go on to the next one, and you draw a line. And you go on to the next one, and you draw a line. Until you get 14 lines in there. Now, what this means is that this is 1 foot here, this is 1 foot, this is 1 foot. Every converging line in there are 1 foot sections. Now, I'm going to use this neat little trick. If you have a square and you draw a diagonal in the square, it divides this into 45 and this into 45. Do we have anything in there for 45? Yes, we do. This line right here, this is the 45-degree angle vanishing point. So we go through this corner over here, through this, either corner, doesn't matter. And wherever that construction line crosses the tracer lines of the floor pattern, you draw a horizontal. And you just walk right on out. And you'll notice that these start getting wider and wider apart as you move away. This, by the way, is called the scale wall. Scale wall, which means that anywhere on this wall, 1/2 inch equals 1 foot. Because it's 4 inches tall, or 8 feet, and it's 14 inches wide. Now, if I want to find a point somewhere in the room here, I just count down and over. So I can locate anywhere in this room that I can see. Wherever I see a grid, I can establish a point. Let's say that 4 feet from this left wall and 10 feet from the back wall is a block in 2-point perspective. So I go down here 4 feet, so it's going to be along this line right here, and I count out 10 feet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this point right here is 4 feet from this wall over here. It's more 1, 2, 3. This one's actually 5. Let's say I'm 5 feet from that wall over there. Well, actually it should be 4 because I said. My drawing isn't exactly to scale, just the concept we're talking about here. And I'm going to draw a block that is 2 foot by 2 foot by 2 foot. It's a perfect block. So what I do is I look on the floor. I can do this 2 ways. I can look on the floor and measure this, because this is 1 foot, 2 foot, and then stand that measurement up. Or I could go back to the scale wall. In other words, I can measure up here 1 inch. That would be 2 feet. Then I'm moving that 2 feet out here. I go back to the horizon line with the construction vanishing point, go through the top of that, out. Okay, that would be 2 feet. Then I got this. I can get the scale off of the scale wall, or I can get it off the grid on the floor. I know what 2 feet is at this point. Now, since it's going to be a perfect cube, I'm going to have a construction vanishing point right, and a construction vanishing point left. And I'm going to be using my vanishing point right and my vanishing point left. So I'll have a line going over here, and a line going over here, and a line going over here, and a line going over here. Now, I really don't have to measure, because on the floor I have what 2 feet is over here. So I go over this way 2 feet, go to that construction vanishing point over there. That's 2 feet. Go over here 2 feet, go to this construction vanishing point. So I have a block that's 10 feet from the back wall, 4 feet from the left wall. That's 2 foot by 2 foot in this room. So I've drawn all this to scale. Now, let's say I want a door going through this wall over here. That the front edge is 8 feet from the back wall, and the door is 7 feet tall. That's fairly normal. So I would count out 8 feet, 1, 2, 3, 4, 5, 6, 7, 8, and draw the front edge of that door. And I would go back to the scale wall and measure up 8 feet and bring that measurement forward. So that door would look something like that. Now, doors are usually about 2 feet, 2.5 feet. So I would go back 1, 2.5 feet and draw the back edge. And I have the opening in that door. Now what I've got to do is get a wall thickness. So I would go back to the scale wall and measure out. Now I'm going to blow this up. Let's say that this is a scale wall. I measure out, and this is a 1/2 inch. Since it's to scale, I measure out this way 1/4 of an inch. Normally walls are about 6 inches. A 1/4 of an inch would be about 6 inches. So I measure out 1/4 of an inch and bring that measurement forward using this line of sight vanishing point. Now the door goes straight through the wall. So the bottom of this is going to be parallel to the bottom of the picture plane. I can draw the vertical. Now I've drawn the thickness of the wall there. All I got to do is draw the top plane of this door. So I go from there, from this vanishing point, now I'm going to do the same thing to the other side. I'm going to do the same thing to the other side, but to the other side, instead of having a door, a normal door, I'm going to have a Roman arch door. In other words, it's going to have a circular side. And let's say it's only 6 feet from the back wall. So I go out here 6 feet, draw the front edge. I go back 2.5 feet, get the back edge. I get the height, we'll keep the height 7 feet. Okay, now this is not square at the top. A Roman arch is a circle. A circle. Now, since this Roman arch is going through the wall, the cylinder is perpendicular. No, it's parallel to the picture plane. In other words, the cylinder goes straight through the wall. When it does that, the minor axis is parallel to the horizon line in the bottom of the picture plane. So I draw just an ellipse whose minor axis is parallel to the bottom of the picture plane, or the major axis is parallel to the sides of the picture plane. Either way. Go down to the floor, go back to the scale wall, measure out 1/4 inch, bring that measurement forward. Okay, that takes care of that. Well, that's an introduction to that. We're going to do some more of this, but for right now, we're going to kind of change gears here for just a second. Actually, that may be a good place to stop. We've been here 51 minutes, and I try to keep these classes to 50 minutes. And so we're going to stop right here, and we'll pick up here next time.